Welcome everybody to our review of the second half of Chapter 5. Our first problem in this review is to write an equation of the line that passes through the given point and is parallel to the given line. So what we need to do first is we need to look at our equation. We need to figure out if this is in slope-intercept form, and it is not, it's in standard form. So we need to move over the 2x by subtracting it. So we get 9y equals negative 2x plus 12. Divide by 9 to get y by itself. So we get y equals negative 2/9 x plus 12 divided by 9. Well, we can't do that, but we can simplify it to a positive 4/3. So if we were to write a parallel equation, our parallel slope has got to be a negative 2/9 as well. So our new equation then has to go through 15, negative 2, so we're going to put y equals mx plus b. Our m is a negative 2/9. Our x is 15 equals our y is a negative 2 and plus b. We need to figure out what b is. So if we do negative 2/9 times 15, that gives us a negative 3.3 repeating equals negative 2 plus b. We're going to add 3.3 repeating. So our b is going to equal a positive 1.3 repeating. So our new equation then is going to be y equals a negative 2/9 x plus 1.3 repeating. Here, we have to again get it into slope-intercept form, but this time we're looking for perpendicular. So I'm going to subtract 3x to move that over. So we have a negative 2y equals a negative 3x minus 4. Divide by negative 2. So we have y equals, now negative 3 divided by negative 2, we can't do that. But two negatives do make a positive, so we can have 3/2x. Negative 4 divided by negative 2 is a positive 2. So this is our equation in slope-intercept form. Our m here is 3/2. So our perpendicular slope is going to be the opposite reciprocal. So instead of positive, it's going to be negative. And we're going to flip the fraction, so it's 2/3. So again, we're trying to get this into y equals mx plus b. So our x is 13, our y is 12. So our y is 12 equals a negative 2/3 times 13 plus b. Excuse me. So negative 2/3 times 13 gives us a negative 6 or negative, oh, hold on. That gives us a negative 8.66 repeating equals 12. And we have to add our b on there. We're going to add 8.66. So we get 20.66 repeating equals b. So our equation then is going to be y equals, now remember we have to have our new perpendicular slope, so negative 2/3 x plus 20.66 repeating. Alright, next one, we have to determine which, if any, are parallel or perpendicular. So we need to find the slope of all of these. So this one is not in slope-intercept form, so I'm going to make it into that form by subtracting 4x. So we get a negative 3y equals a negative 4x plus 2 divided by negative 3. And we get y equals a positive 4 over 3x, because two negatives make a positive, plus 2 over negative 3. So our slope here is 4 over 3. Our second equation, we have to move two things. We have to move the 3x. So we get 4y plus 8 equals negative 3x plus 0. And subtract the 8. And we get 4y equals negative 3 over, or negative 3x minus 8 divided by 4. We get y equals a negative 3/4 x minus 2. Our slope here is a negative 3 over 4. Last one. This is in slope or point slope form, so we need to distribute our 3/4. So we have y minus 6 equals 3/4 x minus 3/4. We're going to add 6 to both sides. So y equals 3/4 x plus 5.25. So our m here is a positive 3/4. Now we need to look to see if any of these are parallel first. We have 4/3. We are looking for the same 4/3. This one is not the same, this one is not the same. So none of these are, or this one is not parallel to anything. Negative 3/4 is not the same as 3/4, so this one isn't parallel to that one either. So none of these are parallel, but we have to look to see if any of them are perpendicular. So I'm looking for the opposite reciprocal of 4/3, and that gives me a negative 3/4. Do we have a negative 3/4? Yeah, we do. We have one right here. So that means that line A is perpendicular to line B, but they're not perpendicular to C at all either. So just A is perpendicular to B. So, alright, this problem says the table shows the living space recommended for pigs of certain weights. So, the first part of this is to make a scatter plot of the data. So we have X is our weight in pounds and Y is our area. So if we go down to our weight, this goes up from 40 to 230. So I think I'm just going to go up by 40s every 2. So 40, 80, 120, 160, 200, and 240. Then on my Y, the area I'm going to go up by, it looks like 1s because it's only going up to 8. So I'm still going to jump by 2, so 1, 2, 3, 4, 5, 6, 7, and 8. So our first point is at 42.5. So 42.5 is right here. Our second point is at 63. Okay? Then it goes to 83.5. Then 104. 125. 156. 238. So now we draw a line of fit through this or these points. Try to make sure it goes through as many, or it doesn't go through any of them, but it stays with about the same on top as the same on bottom. Now it says write an equation that models the recommended living space as a function of a pig's weight. So what we got to do is find points where our line, just the line, goes through our intersections. Looks like we have a point right here at 207. And it looks like we also would have a point maybe right here at 42.5. So if we look for our slope, we can count our rise over run. Looks like we're going up by 0.5 from, well, let's just do, instead of our rise over run, we can do our slope equation. So we have 7 minus 2.5 over 200 minus 40. 7 minus 2.5 is 4.5. 200 minus 40 is 160. So our slope is 4.5 over 160. Let's see if we can simplify that. That gives us about 0.03. So that's our slope. So then our equation would have to be 0.03, and we pick one of our points. I'm going to pick 207. So it'll be 7 equals 0.03 times 200 plus b 0.03 times 200 equals 6. So 7 equals 6 plus b. We would have to subtract the 6 to get the b by itself. What we get is 7 minus 6 is 1 equals b. So our equation then would be y equals 0.03 x plus 1. Now it says about how much living space is recommended for a pig weighing 250 pounds. Well, 250 pounds would be about right here. Be about right here. So if we were going to go up to our line, we would get to about here. And that could be about 8.5 square feet. Alright, our next problem says the table shows the federal outlays for agriculture in billions of dollars from 2000 to 2004. Make a scatter plot of this data. So our scatter plot, our years are going to be our x, and our federal outlay is going to be our y. So our years, I'm just going to be the years from 2000. So our 2000 is going to be 0, 2001, 2002, 2003, and 2004. This looks like I'm going to go up by 5s. So 5, 10, 15, 20, 25, 30, 35, and 40. So at 2000, it's at 36.5. So about here. 2001, it's 26.3. Oh, wait, hold on. 36.5 is right there. 26.3 is right there-ish. 2002, it's 22. 2003, it's 22.5. And then 2004, it's 15.4. So if I were to draw my line through here, so we need to write an equation, so we need to find some points on this line. Looks like we have a point right here at 0.5, so 0.5, 30. And it looks like we have a point that's close to this one, which would be 3 or 4.5 and 7.5. So we need to find our slope first. So our y2 is going to be 7.5 minus 30 over 4.5 minus 0.5. So 7.5 minus 30 gives us a negative 22.5. And 4.5 minus 0.5 gives us 4. So if I divide those to get us a decimal, we get a negative 5.625. So our m is negative 5.625. So I'm going to use this point in my equation. My x is 0.5, my y is 30. So I have 30 equals a negative 5.625 times 0.5 plus b. So if I multiply these together, I get about negative 2.8 plus b equals 30. I would add 2.8 to both sides, and my b is going to equal 32.8. So my equation then would be y equals a negative 5.625 x plus 32.8. Now what we need to do is find the zero of this function. So when we find the zero, we know that the zero is the x-intercept. The x-intercept always has a y that equals 0. So I'm going to put 0 into our equation at y. So we'll have 0 equals a negative 5.625 x plus 32.8. So what we do is subtract 32.8 to get x by itself. So we get a negative 32.8 equals negative 5.625x. Divide that by negative 5.625 and divide the other one by negative 5.625, and our x equals about 5.83. So 5.83 would be about here, which is about where our line crosses the x-axis, and that's our x-intercept. In this, what this means is that almost 6 years past 2000 is where our federal outlay is going to hit $0. So that's where we run out of money. Alright, so this last one says, find the perpendicular sides of the trapezoid ABCD. How do you know mathematically that these sides are perpendicular? Well, we need to find the slope of all the sides. So for side AB, our slope is going to be up 1, 2, 3, and over 1, 2, 3, 4. So BC This one's down 1, so a negative 1 over 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Our line CD, that slope is up again, so it's going positive. 1, 2, 3, 4, 5, 6. And over 1, 2, 3, 4, 5, 6, 7, 8, which simplified would be 3 over 4. And finally, from A to D is going down, so negative 1, 2, 3, 4 over 1, 2, 3. So we need to figure out which of these are perpendicular. Well, the opposite reciprocal is perpendicular. So it looks to me like 3/4 and 3/4 are the same, so those are parallel. But negative 4 over 3 is the opposite reciprocal of A, B, and C, and D. So AB is perpendicular to AD, and AD is perpendicular to CD. Now we're going to skip B and C, and we'll just call it there for our review. Good luck on your test tomorrow.